How's breakout going?
Beautifully.
Okay, one person said beautifully and one person sighed heavily, and that's like the complete range of human emotion. You're due for a little bit of, what is it? So is it like coaching a witness when you tell people what to say in court?
That sounds right.
So, last year, okay, so the section this week is basically, it's like something related to Pac-Man, okay? And Pac-Man is not an oval, because Pac-Man is missing a piece of the oval. We call that a G-arc, okay? There are about 3 slides in here today on G-arc, because yesterday at 4 o'clock, Professor Jed Rembold emailed me and was like, hey, I noticed you didn't put the G-arc in your slides like we talked about last year. That's false. I got it in there in time for today, right? So when you go into your sections today and tomorrow and you see a G-arc, say, oh, yes, I remember this. That's the thing we saw in class. Okay, so I'm going to practice. I'm going to say some words, and then when I say G-arc, you're going to say, oh, I remember this, the thing we covered in class, okay? All right. Orangutan. Bar mitzvah. Waterfall. G-arc.
Oh, wow. That's the thing we talked about in class.
Okay.
On last week. Not today.
Too much.
Okay. Temperate rainforest. Kuiper belt object. Hexafluorine. G-arc.
Oh, that one thing from that one
Never heard
class.
of it.
Okay, one of you is wrong. Okay, no, you've heard of it because we just talked about it. Okay, anyways, there are 3 slides worth of GR content here today. Okay, wait, no, why did I record that?
Well, it was good because we all
Delete the
remembered
button.
it.
Delete the button.
I clearly
Chat, clip
wasn't
that. Okay, breakout is due next Monday at midnight, so you have so long. You should probably be done with the paddle today. Why should you be done with the paddle today? The most likely thing to be annoying and you want to talk to the section leader about is the event listeners. So get the ball bouncing and get the paddle moving before you go to your sections. Then you can figure out gameplay later. PS4 looked good. I actually forgot. So this is very confusing for me, and I understand that there's other characters in the universe, but I forgot that I still am supposed to be responsible for grading problem sets after the projects go out, because I don't grade the projects. I don't know if you all figured this out. So for some reason, the section leaders grade the projects and I grade the problem sets. I would have thought it was the other way around. No one asked me, and it doesn't matter. What this means is that I didn't look at any of your problem set 4s because I forgot it was my job, okay? So in a panic, I looked at a bunch of them yesterday, and they seemed fine, but that's why you haven't gotten feedback. I literally forgot it was me, okay? So someday someone's going to look at those problem set 4s, but I don't know when because I also assigned a bunch of midterms that I also have to grade. So just assume you did well on problem set 4. A good way to tell if you're doing well on problem set 4 is if you're working on breakout and you can do it, right? If you can't do it, maybe the problem happened on problem set 4. So talk to your section leader in either case, or you can talk to me if you want. Okay, today. Sorry, I just saw these glasses here. Now I'm distracted. Is this anyone's glasses? There. Let's check. Wait, did that actually make my vision even worse? That's never happened to me before. Okay, those are probably not mine. Oh, I bet if I wear my contacts and my glasses and then put those on, it would be better. Okay, so today we're going to learn about lists. Why are we going to learn about lists? Because they're awesome. I was a bit surprised the first time I taught this class how late we learned lists, because when I teach Python, lists are usually the second thing I teach after print. And that's okay, because we did strings instead, which are pretty similar. But let's think of it this way. Computers are good at doing the same thing multiple times. For example, we can tell Carol to move until reaching a wall. We can also, for example, tell a computer to compute the twisted Edwards curve, which was the thing I just showed you, over 1,000 data points, and it will make no mistakes. But if I had to raise something to the third power 1,000 times, I would get every single one wrong after the 10th time because I'm tired. So computers are good at doing things multiple times. is with Carol. We did this with Wordle. We're now going to do it with Breakout. So each brick will have the same thing happen to it. And this is motivated by some of the old software engineering trends, and even before that, just computer science trends. So for example, every time you purchase something on Amazon, the same sort of things happen. And I think Amazon actually changes how they work all the time now, but probably they still sell a million things every way they sell one thing. So most of these are repeated actions, but they are not necessarily repeated actions over the letters of a string. So the letters in a string is a special case of a way to have repeated actions. So we're going to use the more general form, which is going to be a list instead of a string. How does that work? I'm going to introduce some terminology because it is helpful to have these terms. A list, like a string, is a collection. The collection is the category of thing that lists and strings fall into. Something is a collection when it can have more than one of something inside of it, right? So it is like a bag or a knapsack or a grocery cart. A list is a specific type of collection. It is an ordered collection. Not every collection is in order. For example, my favorite students ranking is unordered because you're all in first place, right? Yeah, right? But the order in which I go into the classes in a day, even though each one of them is my favorite, I still go to them in a specific order. So times are ordered, for example. So classes are ordered by time, but not ordered by favoritism, right? Things inside a list, I usually refer to those as elements of the list, and I usually do this with all collections. The only exception is the string, where I refer to the elements of a string as letters. So why do I say elements instead of letters? Well, what if I have a list of numbers? What if I have a list of lists? What if I have a list of automobiles? I'm going to use elements as the general way of referring to things inside a collection. So I have a collection of elements. The number of elements is the length. This is the same as strings, unaltered. And like strings, each element has an index, and in fact, all ordered collections, every element has an index. And that is the way you tell if it is an ordered collection. If elements do not have indexes, then it is not an ordered collection. Okay, so let's have an example. Say we have 100 bricks. That's a lot of bricks, right? How many of you have 100 bricks? All of you have 100 bricks because the hope was that you would get to that milestone by today, right? So we all have 100 bricks. So when I say, do you all have 100 bricks, I would like you all to say yes. Okay. Who here has 100 bricks?
I do.
That's what I thought. That's great. Okay, that's you all are very good at this. Okay. And I want to take my 100 bricks, and I want to put them in groups. Notice I don't say lists. Notice I don't say collections. I'm just grouping them up. I'm using a different term. Group is also a technical term in mathematics, but we generally avoid using that. Sometimes we say families. But anyways, I'm going to take chunks of 20 bricks, okay? And I want to color some of these bricks the same color. So who here has heard of the yellow brick road? Right, that is differentiated from other roads by other roads themselves not being yellow. So only some of the bricks are yellow, right? So the way I'm going to solve this problem is I'm going to make a list of colors, and then when I make my bricks, I'm going to look up in that list of colors what color my brick should be. So how am I going to do that? Well, it's like making anything else in Python. I'm going to create a variable name, and then I'm going to use the single equals assignment, and I think I can go ahead and do that now. Let's see. I wonder what folder I have open. Open folder. What is freeze? I'm sure Wordle's fine. Okay. Open. Okay. Wow, look at all the things that are open here. Okay. So, we can go ahead and say colors equals, and what do we say colors equals? Colors equals, and it could equal, for example, red. But that is a singular color. I'm just running this to show that I didn't get any errors back, but we can go ahead and print colors and see what we get. Is this too zoomed in? Better? Worse? Do we like this?
I like that.
You like this? Okay. So there we have it. We have red. Red is a singular color. That is not enough colors. I think the colors you use on Wordle are red, orange, green, cyan, and blue. Did I make that up? What color are they in Wordle? Or not Wordle? Breakout?
Those are the colors.
These are the colors? Cyan?
Yeah.
For real?
Yeah.
I have no memory at all. So, this is just a comma-separated list of values. I'm not supposed to show you this. I'm gonna break the rules a little bit. This totally works. You're completely allowed to do this. But this is something I haven't shown you yet. Let's see, type of colors. That's a tuple, and you're not allowed to know about those yet. So instead of knowing about those, every time you type in your lists of values separated by commas, always put them inside of boxy brackets, right? Boxy brackets is the thing we use for collections, and we're accustomed to using boxy brackets because we use them to look up the indices of things in strings, right? And so this comfortably turns us into a list. We have a list, and we are denoting it with boxy brackets. Okay. And we're used to seeing boxy brackets because if your name is, what is a name? Glorfindel. I'm doing my best here. You would use boxy brackets to look up a letter in the name, and that is R, right? So this boxy brackets notation is commonly used for everything when we're doing stuff related to ordered collections of elements. Okay, so this is how we create a list in Python, and how do we use it? I'm going to introduce sort of a novel way to work through this today because I think it's a little bit easier. This is also motivated a little bit by showing you the command line at the beginning of class. Besides just typing things inside a Python file and then running them, I can also open Python here. And I think you will want to type Python on Windows and Python 3 on Mac, but I'm not sure. And then I can put in many of the same elements of the code I have been previously, such as 6 plus 7 equals 13, which is true. So I'm going to use this, which is called the REPL, read, evaluate, print loop. So basically things are going to print when I put in the values of expressions, just as a way to show some of the things we're teaching today. This may or may not be a helpful way for you to understand and test your own code, but this is a way I understand and test my own code, so I thought I would show it to you. I waited to show this to you until after the first midterm, so this is a post-first midterm topic. Okay, so this is how I'm going to show code today. And let's just take a look at how this works. So let's go ahead and create colors. I'm just going to copy-paste this because I don't want to spell a color wrong. So here's colors. I'm going to paste that in. Okay, and what are some things I can do with colors? Well, first I can look at colors. And when I look at it in the read evaluate, so it reads colors, it evaluates colors, and it looks up that it is red, orange, green, cyan, blue. Then it prints out what colors are, and then it loops back to showing me the 3 arrows. That is the same as if I just ask for printing colors directly. I have some carnage here in just how that's showing up on my screen, but I'll just print that again. Nope, it really doesn't want to print that way. Print colors. There we go. So this is what a list will look like if you print it out. What are some things I can do with colors? Well, I can look at the type of colors. Wow, why is it doing that? That's so strange. Type of colors. And the type of colors is of class list. We are probably familiar with type from checking what the type of 1 is, or checking what the type of, what's something else I should check the type of? A string, perhaps? Wow, that is the most annoying thing I've ever seen in my life. I don't know why it's doing that. Wow, this is, wait, should I click this button? Control click. Is that less bad? Oh, this looks much worse. This seems perhaps more terrible. Wow. I'm miserable right now. Okay. Well, anyways, it seems like it works if I press enter a bunch of times between everything, so I'm just going to try and remember to do that. Okay. Once again, I am not sponsored by VS Code. Okay, so let's see. We can look at the type of... Wow. Why? I'm very confused by this. Okay, so here's colors. We can look at the type of colors. We can look at the type of one, and we can look at the type of a string. What else have we seen? We can look at the type of print, which is a built-in function or method. So we can use type to check out what type of thing we're working with. And this will be potentially useful for us today. A common mistake that beginning programmers make is ambiguously referring to a collection of elements and elements of the collection using the same word. So I think oftentimes we expect maybe to refer to the first thing on the list and the list itself as the same thing, right? We could say, for example, I'm going to do my to-do list. This is false. We don't do the list. We do the items on the list, right? But it is not common to make that distinction in spoken English, for example. Okay, so what are we going to do here? Well, we've shown this type, and we've seen what the colors look like. But we can also manipulate this list the same way we can manipulate strings. So we'll go ahead and put in, and let's see, I used a name last time. What was the name I used? Tenerviel. Okay. Any Tolkien snobs? So Tenerviel is supposed to have an accent on it somewhere, but I don't know how to type that in. Okay. So if we look up the fourth letter in Tenerviel, it is the letter after 4 other characters. If we look up the fourth color, it is the color after 4 other colors. So red, orange, green, cyan, blue. We can loop over colors for, I'll say for color, in colors. The name is not meaningful. I can put X in color. For X in colors, print color. And I can do the same thing. Oh, print X. There we go. And I can do the same thing with for letter in name, print letter. So these loops function the same way. I can also do the same thing I have done in the past with string loops, where I can do I in range length, which is the size of the collection. So I can say for I in range length name, print name I. And I will get the same result as if I print all of the X's in the collection. And then separately I can say for I in range length colors, print colors I. And this will give me every ith color beginning at 0. So red, orange, green, cyan, and blue. And let's review what colors looks like just so we know what we're looking at. 0, 1, 2, 3, 4. Blue is index 4. Potentially useful. Okay. We can also take slices. So we can do all of the typical slices. And what are some of the typical slices? Perhaps we go from 1 to 3. Perhaps we take every other color. Perhaps we go backwards. And of course we can do all of these same things to name. We can reverse Tenerviel. We can take every other letter. We can take letters in the middle. Ooh, that's a little goofy that says in. I'm going to change that to 5, right? So the same way of indexing ranges and the same way of indexing strings we can use to index into our lists. You're all looking slightly more horrified than normal today, but I promise this is all extremely normal. We can also use negative indices, which I should review those again for you. So the negative 1th letter of name is the L at the end of Tenerviel. The negative 1th color is going to be what? I'm blue, abadi, abada. Abadi, abada, abadi, abada. Right? It's blue. Note we do have quotes around these. This is different than if we printed them out, where we would lose the quotes because we're just showing the string. Okay. There's my slices. And there are some things you are not allowed to do. Let's show an example of a few errors, as I am expecting you to experience these errors at some point in your life. And actually, I'm going to go back to VS Code for this, because this is how I expect you to see your errors in real life. Why did I say real life? Nothing we do here is real. Okay, so if I try to look up colors 0.5, I will get an error that list indices must be integers or slices, not floats. This is more common when we accidentally do something like 5 divided by 2, and we get the same error, but we'll also get the same error if we just put name there. We are never allowed to look up non-integer or non-round number or fractional addresses. There is no, I don't know. So I use the example of an ordered collection of the classes I teach today, which is teach this class, then IDS 101, then CS 271, right? There is no 2.5 class. That doesn't make sense. That's not meaningful, right? So it doesn't make sense that we can look this up. I want to give you an example, because every once in a while someone says, Calvin, why don't you ever show us anything real? Well, there's nothing more real than the Cook Partisan Voter Index. I forgot what PVI stood for. I had to read my slides. Because I don't know what makes it real. They're numbers that are collected by social scientists, right? So I want some credit for this is social science. Someone went out and looked at votes or something, right? There's a lot of people that hang out outside of my apartment every day, and some of them are protesting that America is a democracy, and some of them are protesting that it's not, but they're all on the same side. It's very fun. Okay, so here is the Cook Partisan Voter Index. Ooh, that's not what I copied. Let's try again. Copy. Wow, that's really long. I wish I were really, really good at working with lists so I could look at parts of this somehow. If only there were, because if I just print this out, yeah, that's really hard to read, right? Maybe there's a better way to do this. Maybe I can look at every row. So perhaps this appears to be a list of states. Okay, so maybe I'll look at for state in Cook PVI. I'll just print out the state. Oh, that's way easier. Isn't that better? That's maybe not great, but that's better, right? This is kind of looking an awful lot like a spreadsheet or a data frame, right?
Whoa.
Yeah, that's what I thought, right? That was pretty horrifying to me when I realized that. This is still a lot to look at. Wonder if instead I could just look at the 0th entry in each state, which I think is going to be the name of the state. Oh, and that's just the list of the states. Okay. Well, that's not bad at all. I can completely manage that. Well, I wonder what else I should look at. Well, this first thing, I think this is partisan lean, which is the average partisan lean over the last 5, I believe, presidential elections, but that maybe doesn't make sense because these look like complements of each other. Where's Colorado? I actually know what's going on in that state. Okay. No, I don't know what's going on in that state. That's fake. Colorado became a blue state when they put marijuana on the ballot, and it never went back. Smoke weed every day. Okay. Am I allowed to say? I'm probably not allowed to say that. So, I can look at the partisan lean, and this isn't particularly meaningful because I don't know what state that D plus 16 is, and I don't know what state the R plus 25 is. So, instead of doing that, let's print out two things. Let's print out state 0 and state 1. There we go. Maybe that's nice. And you know what? Actually, there was a more clever way to print that out. What I should really be doing here is I should just take a slice and print that. And this is the same thing. What am I doing here? I'll pull up the slice. I am looping over the list, and this is a list of lists. So for each element in the list, it is itself a list, and I'm taking a slice within the list. Not too bad, right? This is a little bit annoying because the states' names are different lengths. Not to worry, I have a plan. I can look up the 0th element of the state, and let's just check what type this is real quick before I fiddle with it too much. Those are all strings, right? Alabama is a string. Roll Tide. Any Roll Tiders? No one rolling Tide? Okay. That's okay. We don't have to roll Tide. Why don't I just take the first 3 letters of the state name? There we go. Those are probably pretty recognizable to us. And then from there, I can also look at the partisan lean. And I think this is actually positively readable. I don't know about you, but I can probably guess that this is new, right?
There are 2 missing.
There are 2 misses. What do we think they are?
Couldn't tell.
I think they're both Mississippi. They also have the same partisan lean, so it doesn't matter, right? Here's Mick, Mass, Mary, Maine. Oh, Maine's the same. Shout out Maine, Maine W. Here's Kent, which is in Ohio. Here's Cans, Iowa, Iowa unaltered. Iowa W, right? Here's Floor, Dist, yeah? They get to vote, the District of Columbia. So anyway, maybe this isn't too bad. So I heard some haters on the new thing.
Yeah.
And I think we know string methods, right? No, I'm not going to fiddle with that right now. Anyways, this is how you work with lists, okay? All right. Here's an example. Here's an example. Oh, yes, taking, this can be much more fun. This was a lot of states to look at. What if we only look at 5 of them by taking every 10th state? I don't know. That's pretty nice. I can actually understand that. And there's states on here I've heard of, right? So I grew up, okay, calm down. I feel like my haters are on the prowl, you know, right? I know where Wyoming is, right? And I know that that's a petro state with a very small population, so very strong R-lean because there's no urban centers. Every state was new in the name, obviously. Oh no, Maryland, right next to the DMV area, which stands for District of Columbia, Maryland, Virginia, right? Lots of national security contractors there, so they tend to lean Democrat for some reason. Alabama and Georgia are both in the U.S. South, though Georgia has Atlanta in it, right? Very large urban center pushing it in a D-word direction. And both South Dakota and South Carolina, I think, are around +8 anyway. So there you go. This was fun and made sense. Okay. Now, I think some of you were spreading vicious lies earlier that I hadn't taught you what a G-arc is, right?
No.
Yeah, no one was saying that, right? So let's go ahead and let's GARC it up, right? So I'm going to go ahead. I'm actually going to close this because it's just distracting me now. And I'm going to do what the kids, and I've been listening to the kids carefully, refer to as hitting a Piggle angle. I'm going to import PGL. Psych, I'm not. I'm going to from PGL import star. And you know, I'm not even going to do that either. I'm going to import Gwindo and GARC. Doesn't that sound fun? We got Gwindos and we got GARCs.
Kirk sounds like I'm really surprised, but also tripping.
Okay. And so what are we going to do with our Gwindos and our GARCs? Well, we're going to do what any enterprising data scientist would do. Are any of you in Data 151?
I'm in the one after that.
The one after that. Were you all taught not to use pie charts?
Yeah.
I'm going to make a pie chart. Out of spite. Okay. So it's okay because we're not doing it for real. We're doing it ironically and out of spite. So it's fine to do it that way, right? Okay. Do not tell any. Oh, you can tell them I made pie charts. Okay. So we're gonna make a pie chart because I don't know what else to do with GARCs. Okay. So what are we gonna do here? Well, I'm gonna make a Gwindo, and I'm just gonna go ahead and make it have some width, which is perhaps equal to 800. What am I doing? Okay. So we're gonna hit 2 W's there, not a single L, both W's, right? Okay. And I'm going to say that window is going to be named GWA, right? Let's go ahead and run this and see what happens. Oh, it's a graphics window. And it's a graphics window that also can potentially contain information about the Cook Partisan Voter Index. So, what am I going to do with my graphics window? Well, I actually don't care about every state. I only care if they're RUR or DUH, right? So I'm going to create an count of ERS, which is the R lane states. I'm going to set that equal to 0. And I'm going to create DS, which stands for deep space, which is the prefix of Deep Space Nine. Is that a Star Trek? You're not Star Trek?
Star Trek, yeah.
It's Trek. Live long and prosper, maybe? Yeah. Anyone know Klingon? No. Okay. All right. We got a little too nerdy there. We were okay for a while. What are we going to do here? Well, let's loop over the Cook PVI for state in Cook PVI. Well, let's just start by doing a simple print statement. So let's go ahead and print state 0, okay? That's state 0, that's the name. Okay, what is state 1? Okay, so state 1 either starts with R or D, right? Well, in my infinite wisdom, I can simply write an if statement. What am I going to check? I'm going to check the 0th letter of the 1th field of my list, okay? So I'm going to take 1, 0. No, I did a whoops. I did a whoopsie daisy. Okay. We're going to say if this is equal to R. Print R. Okay. So what's happening here? I'm printing the partisan lean of every state and also talking like a pirate. So that's 2 good things at the same time, right? I notice you're not making impressed sounds, but I got my computer to talk like a pirate, right? Okay, all right. So, maybe that's cool. And computers are good at doing things repeatedly. So what I'm actually going to do here is I'm going to just increase R's by 1 when that happens, and otherwise I'm going to increase D's by 1. And then when I'm done, maybe I'm just going to print out R's and D's real quick and see what my count is. Okay, so I have 31 of one of them and 20 of the other, and I think that's R's first and D's. This makes sense. There's the well-known Republican small state bias, right? Any social scientists? So like every single Democrat lives in California, right? And California has 130 times the population of Wyoming. Okay. More people live in LA County than Oregon and Washington.
That's crazy.
Right? That's like not even made up. Like I don't even have to make that up. Like I could make things up that aren't true too. Like more people live in LA County Airport than on the moon. That's also true, right? Like okay, so anyways, never let your haters get you down. Okay, so what are we gonna do? We're gonna GARC it up. Okay, and the way we're gonna GARC it up, the manner in which we're going to GARC, is that we're gonna add GARCs to our Gwindo. Okay. They're going to be called GARCs, aren't they? I should call them GARCs just to seem normal. Okay, well, we'll deal with that later. And so I'm going to first create a RARC. This is the Arlene ARC. Okay, and I said Arlene, but it sounded like I said Arlene. That's not my fault. Those names just sound the same. Okay, so what is this going to be? This is going to be a GARC. And GARCs have many arguments, right? There are so many arguments. The way we remember this is they have many arguments in the hollowed halls of the United States Congress, right? Nothing is more hollowed than that, right? And they have many arguments there. They have exactly, in fact, 6 arguments. The 6 arguments are the x value, the y value, the width, the height, the start, and the sweep. What are start and sweep, you ask? Well, I didn't know either, and I couldn't tell from the documentation, so I just put in random numbers until it started working, and that's what we're going to do right now. Now, if this were a Goval, And let's go ahead and make a Govel real quick. Oh, I can't, so I have to add Govel up here. We could, for example, just put in 0, 0, 800, 800, and make a Govel about the size of our window. Did we actually make it?
Did you add it?
Did we add it? That is a good question. So let's GWAD our Rark. I feel like I'm unraveling, like more than normal. Okay, so there's a Govel, but we don't want a Govel, we want a Gark, right? So let's just change this over to Gark, and I bet it'll work on the first try, right? What are the odds it doesn't? That would be crazy if it didn't work. Wait. Oh no. Oh, I think it was supposed to work. Oh no. Oh, should we panic? Wait, no, here, okay, this slide says what to do. Okay. We need to provide, the 6 arguments, because Congress is always arguing, right? Okay, so we're going to provide start and sweep as angles given in degrees out of 360. Shout out Charlie XCX. That's the only way I remember there's 360 degrees in a circle. So let's go ahead and let's do a 90 degree, right? Because that's the temperature I thought it was going to be. Well, okay, so that's basically impossible to see, but that looks an awful lot like a quarter of a Gark, doesn't it? No, sorry, a quarter of a Govel. You think that's a full Gark and a quarter of a Govel? Yeah, that's what I think too. So, seems like we should make things a little bit easier on us, especially those of us with the old bad eyesight. So let's go ahead and set our Rark to be filled. Set filled. No. Set filled. True. That's a seriously Gark-looking Gark, huh? There are many Garks like it, but this Gark is mine. Okay. We're going to go ahead and bring this down, because it's beginning to annoy me. Okay. And what do we set the fill color to? So a lot of people don't know this. The R in the partisan lane, that stands for red, right? Okay, so we're going to set our Rark's color. Set color to red. Okay? And then what are we going to do? Well, my ingenious genius plan, was to take the number of R states, divide it by the number of total states, and multiply it by 360 degrees. But we don't have to do that. We can actually just start by taking the number of red states and putting them here. And this will probably do something. Nope, it won't. I have to trash can. Okay, so that is informing me of something. So I'm guessing this line here is the 0 angle, and this line here is the 31 angle. But that's not really enough, because, let's see, what are there? There's 50 states and 360 degrees. Shout out Charlie. One of the best to ever do it. Okay. That looks about like 31 divided by 50 times 360 degrees, right? Okay. As Pez, let's go ahead and hit a dark. Nope. Let's dark it up. We're going to set the fill true, and a lot of people don't know what the D stands for, and it actually stands for Duke Blue. Please work. Dang it. Dodger. I know it's a sport. I know it's a sports thing.
Why are you just doing
I'm adding the wrong thing.
It says R.
Maybe it was working the whole time. Wait a minute. Is that extremely wrong?
Yeah.
What should I do?
Maybe it's negative?
A negative?
You should start from the end
I should start from the end?
and go back.
Bringing back unit circles.
Yeah.
I should start from the end and bring back unit circles?
Don't bring back unit circles, but you should start from the end.
But from that.
Negative sign on the DS.
You think I should put a negative sign on the DS? Seems... I mean, what are the odds that works?
Whoa.
Okay, so that they were pretty good in this case, but they didn't have to. It didn't have to work
No.
because we haven't read the documentation, so we don't actually know what the start and sweep are. And then what's the alternative to that? Not to worry, I've got you. You can start at the same place you left off.
That works.
This might work. I've never tried this before in my life. Ooh, that's a little sketchy. That kind of looks like a rounding error, though, don't you think?
I'm pretty far past it. Never mind.
It's a pretty juicy rounding error. But we are multiplying big numbers together. How different does it look?
We get at least 10 degrees.
What did we do before? It's not that different.
It seems pretty relevant.
But I don't know if the people in that 10% deserve rights. So, like, chat, do not clip that. Whoever they are, I love and respect them. Okay? Okay. Anyways, this is my code. I did the negative. I don't know if some of you were cheating. Oh, it is Dodger Blue. Yeah, sorry, I confused Duke and the Dodgers because they're both teams that I don't know what sport they play. This is what it looks like in HTML. And that's visualizing. Okay. So on the count of 3, we're all going to say what our favorite graphics, what our favorite portable graphics window graphics shape is, and we're all going to say either GARC or GARC. You get to decide how you say it, okay? But it's our favorite. We're assigning favorites.
What if I like a different one?
Then you lie. Okay. So I'm going to count to 3, then we're all going to say our preferred pronunciation. I'm letting you pick how to say it. It's, in a way, there's many possible choices, but I'm restricting you to choose one of 2. Do you see how that's relevant?
Pronounce it differently.
It's the illusion of choice.
It's the illusion of choice. Okay, 1, 2, 3, GARC. See, that's fine, right? Yeah, we count those. Okay. All right. Most things that work for strings work with lists. We can add them together. My colors are gone. Does everyone like Colors by Halsey? Banger song, right? No? Okay. Oh, I completely highlighted the wrong thing. Colors equals. Okay, so this works. We can print out colors, and we can also print out colors plus colors. What's that going to be? Ooh, oh, it's twice as long. It's twice as many colors. Maybe that's interesting to you. I don't know. Can we subtract colors from colors? No, what would that mean? How do you...
Well, thicker hexadecimal representation, you can operate on that.
But that's still suggesting a vectorized operation, which is distinct from how the list operations have worked in the past in this class, right?
Yeah.
Yeah, I kind of feel like you played yourself there, but that was still pretty clever. I'll give you full credit for that. Would you like a gold star?
You have one?
Yeah, you can have a gold star.
I'll take yours.
Okay, here you go. Okay. All right. What if we multiply them? Ooh, that's not allowed either. So I guess it's just addition? Well, that's kind of disappointing. Okay. Well, what else can we do? We can look at individual elements. This is the tooth color. So when anyone ever asks you what color your teeth are, the answer is green. Right? That's the tooth color. Okay? My dentist loves me. My hobby during COVID was dental hygiene. And then I had to start going outside again and instantly got cavities because I didn't have a very efficient system. I just spent all day putting fluoride on my teeth. Anyways, life comes at you fast. Okay. Now, if I look at the tooth element of colors and then I look at colors again, colors is unaltered. This should not be surprising to us. Every time we look at a letter in a string, we don't change the string. Now, lists are fundamentally different from strings in one important way, and it is that they are mutable, which means they can change. It's from mutate. So I can mutate the value of colors. And what is one way I can do that? Instead of looking at the tooth element, what is happening? I can pop the tooth element, okay? So I'm going to instead here pop 2. It's still going to tell me what the tooth element is, but in addition to telling me the element, it is also going to remove that element. Okay. Colors is as entered. Red, orange, green, cyan, blue. I pop 2. That's the tooth element, which is green. And then green is absent from colors. Would this have been like kind of nice on Wordle?
Yeah.
Yeah, that's crazy, right? Let's pop another one. Sometimes people's teeth change color. Mine changed from green to cyan. That's a common color transition that my teeth go through. Should we do it again? Ooh, now they're blue. And why is that? Because I'm continually popping different colors out of the list. I wonder what happens if I do it again. Ooh, oh, I committed a crime. What is the crime I committed? I attempted to pop the tooth element out of a list that only has a 0th and 1th element. And I get set directly to index error. So make sure if you pop something that it's in the list first. Okay. You can also update values of the list. And how can we do this? Well, here's an example where I'm going to replace... I guess in the spirit of this class, I should replace something with olive drab.
I agree.
I know, I like to play to the crowd. And so we'll replace something with olive drab and we'll replace something with either pink or hot pink. I never remember which one we use. So let's go ahead and get rid of all of this nonsense here where we're popping teeth. Let's go ahead and look at colors. Let's set colors 1 to be equal to olive. Is there a space in it? No one knows? The olive drab enthusiasts got curiously quiet there all of a sudden.
It just doesn't matter.
Nothing matters.
It works either way.
Okay, so we can change colors 1 to olive drab. Orange has disappeared and been replaced with olive drab. And we can replace cyan with hot pink. And we can do that. And, did that not work? I didn't print it. Okay, print colors. There we go. So you can mutate, manipulate, change, update, whatever you want. You can change the values in the list. Now, if I try to do this with names, anyone have a name we should use?
Calvin.
One of my least favorites. Okay. If I say name 3 equals, let's see, that's replacing the V, so we should change it to a B. This will cause your code to explode. Ooh, type error. A string object does not support item assignment. Cringe, because I was going to type Calvin. That would have been fun, right? So you are not allowed to use this assignment technique. So this is new for today. Do not forget this. This is the most important thing in the universe. All Python code looks like this. Okay? Got it? Lock in. You got it? Are you visualizing? Visualize success. Okay. Your mantra? Look up things in lists by indexes. Okay. All right. My claim is that you know what every line here does. I don't know if that's true. Is that true? I don't think there's any new lines here. So this is just creating aliases for brick width, height, and separation. It's initializing an x value, initializing a y value. Then you're going to loop over n rows and n columns. I have a debug print statement. You don't have to use that. I'm going to create a brick, which is correct. I'm going to set it to be filled, pink, and I'm going to GWAD it. And then I'm going to change my x value. Have you all done this? You've all done this. Okay. Not to worry, I have a plan. I don't have enough of p2.html. Wow, look at all this stuff. Okay. So we'll go ahead and pop a yoink on this. And then we'll go ahead and, where is the code? Okay, we're going to put this inside of breakout, right? Is what I'm doing make sense? Am I losing my mind? No, I think I'm okay. Debug not defined. Okay, not to worry, I have a plan. Debug equals true. Okay. Oh look! Wow, that's really small. Why is it this small on your computers?
Yes.
Oh my gosh.
It's very small.
Why? This isn't gonna work, is it? Oh no, it's fine. Okay. So just change these if you're annoyed. Probably. Talk to your sec. Do not in any way do what I tell you. Do what your section leader says. Okay. Okay. So here's this is Pink City, right? Okay. Now what can we do? Okay. This is looping over rows and it is looping over columns. This means we know the number of the column. How do we know that? Well, we can just go ahead and print it out. In column call. Is it working? I don't know what it's doing. There we go. So I can say what my columns are. I don't. You color by row, not column, right? Did I make that up? Okay. In row. Okay, so that shows me all of my rows. And then, so instead of doing pink, I can say, well, I can create a list of colors. Do I still have, okay, can you remind me what they are? Or I'll just make them up. Red, orange, green, am I close? Cyan, blue? Why do I have that memorized? That's weird. Colors, row. Oh, my code exploded. Why is that? That's so crazy. My code exploded because I thought it would work. I was sure it would work. That's why I wrote it. The list index is out of range. I wonder if that's because I have 10 rows and only 5 colors. Does that seem possible? You don't think so? All right. Well, I'm just going to divide row by 2 and see what happens. And if it works, one of us is going to be eating our hat or whatever you do. It's actually extremely cool. Is that green looks an awful lot like olive drab to me. Hold on, just a sec. I have an ingenious plan. Colors. Wait, is it 2 equals olive drab? Yeah, I can't even tell the difference. Okay. Anyways, the reason I asked to teach lists at this point in the semester was specifically so you could use them for bricks. That's why I asked. Now, I should caution you something. You should not put the bricks in a list. That's fake. That will not actually help you. Now, no one can stop you. I certainly can't. But you don't need to put the bricks in a list. So, if you're doing that. I think that's all I got for today. Do you want 2 minutes back? And, does anyone have any questions? Cool. I'll see you on Friday. Have a good day. Hope you're enjoying Breakout. Oh, what's your favorite PGL object? Oh, it's a GARC? Yeah. And if you like GARCs instead?
No.
They're the same thing.
Yeah, I think we should make the section leaders have to respond to us saying GARC. I think they'll like that.